I gotta stick this back. We are live. Let me put this back up a little bit. Back this up. I don't want this to be in there. And I think I might have to back this one up too. All right. Folks, we are live. So today we'll be finding the main range and intercept of a function. And I know kids have a lot of problem with this. So I'm gonna I'm gonna try I'm gonna try to make it as easy as simple as possible for you guys to understand. Uh, I'm trying to go live on TikTok. That's why I'm messing with my phone. So, uh, yeah, let's do this. Um, somebody's live. Let's see who's coming on TikTok. So, and that's what we're doing today. This looks a lot darker than I expected. I don't know why. Uh, let me see who's coming. Lee underscore Leslie is here. What's going on, Leslie? Um, let's see who else is gonna pop up. So today is all about domain, range, and what you call this, zeros of a function. And we're gonna do a couple examples and then call it a night. I know it's late. It's about 11 o'clock almost. Yeah. So whoever else on YouTube, say what's up. Uh, no, it's not. It's not really that hard. I show you how to do it, Leslie. What class are you taking? Um, what class are you taking, Leslie? Maddie, A, B. What's up? All right, no problem. No problem. Glad you're here to learn, Leslie. Let's go. This is what we're gonna do here is applicable to uh, no problem. Uday Awula. No problem, man. Yeah, most of my YouTube channels are like ACT and SAT math, so I'm glad that you find them helpful. Katie O. Ryden, negative negative 3 to the third power. So what you want to do? We're gonna do it with the parentheses first. Let me put it right here so I can remember to enter that for you. Negative negative 3 to the third power. And if I write it wrong, let me know too. So I wrote it down on the board. I'll help you with it. What's going on, NGJ, Sylvana, Dubrich, what's up? Lena Mary 10, Trippy Hippie O underscore O. What's going on? The names are clever, guys. Uh, yeah, what's up? So I'm gonna get this going, and then so we can move on to other stuff. So let's see, YouTube. I know you guys gonna be able to see me. If not, let me know as well. Trying to find the best way to bring this to y'all. Let's see. Can bring this closer, maybe. My, I don't know why, but I don't look. It looks really dark from here. I don't know what's going on YouTube. I look really dark from here. I hope y'all can see me clearly though. Uh, Maybe it might be my computer too. Math. Yeah, that's right, man. Some late night math. Um, yeah, so no problem. Cosette winner. No problem. If you can tell me how I save your whole life, would be I would appreciate it. No problem. No problem. All right, let's go. Let's go, guys. I think it's enough of you guys to start. Let me bring the camera around. All right, so I'm gonna kick this chair out of your way. a little bit. But let me know if you're able to see the screen clearly. All right, I'll answer your question a little bit, guys, about the SAT. All right, let me know if you're able to see the screen clearly. If not, let me know as well. So let's start with these. So the first thing I want to do is calculating the domain and the range, and I want to explain it to you guys in a way that makes you able to understand it. And the way that I like to think about this is in terms of input and output. So whenever you have a function, it's like a relation between a set of input and an output. But also that relation, it associates each value of the input is only going to one output. So let's say I'm having input here and output here. Input, and I'm trying to explain the function output. What the function does is it takes the values of the input, A, B, and C, and it associates them to the values of the output. Let me use a different color. Not very different. Let's see. Black. So 1, 2, 5, and 7. So each one of the input corresponds to a value of the output. So let's say I have 1, 2, 1, and 2 on me. So this A can go to 1, this B can go to 2, the C can also go to 2. Now, and this is not confusing because this is still considered a function. Why? Because what we say is each value of the input is only corresponds to one output. So that means this only has one, this only has one output, this only has one output. It doesn't matter if this output here goes to this and then it goes to that too. Both of them goes to 2, so it doesn't quite matter. That still makes it a function. So that's what a function. Instead of a relation, if you had a relation, some of these would go to the same, to 2 different, you see, there would be 2 arrows coming out of the input. So if you have anything when you have 2 arrows coming out of the input, it's not a function. So in plain terms, this is what I like to think about when I think about a function. So whenever you have, let's say you have a stove. So when you put raw chicken inside of a stove, when it comes out, it's cooked. So if you put, raw fish, when it comes out, it's cooked fish. So that's what the function does. It takes the input and it does something to it, and then it spit out the output. It could also give you the same output too as the input. So let's say if you think about the function f of x is equal to x, whatever the value you input here is going to be the value of the output. So 1, you put 1 in it, it's going to give you 1 out. You put 2 in it, it's going to give you 2 out. Not that much interesting. So now in input and output, this is exactly how you think of a function. You have input, a set of input, you associate that, the function make it, they give you a bunch of output. Now, what we're going to calculate is what we call domain and range. I can't find my eraser, so my shirt's going to have to pay for it. What we're going to calculate here is what we call domain and range. So let's go back to the example of the stove top. So the domain in the stove top is the set of input. So still thinking about set input and output. So the domain is on the left is input. So what can go inside of the function? And just like a stove, the oven, if you cannot put, I don't know, you can't just throw your shirt in the oven when it's on, it's gonna burn. So if you consider that as a foul, if you consider that as something that you're not supposed to do, so that's the same thing as the domain. The domain is just like the set of values, the input that you can put inside of the function, where you have a value that makes sense. So think about a function. Let's say if we think of a function, let's say I have a function f of x, a simple function, is equal to 1 over x. That's a function. So I can't possibly put 0 for x. So the input of this function cannot be 0, because 1 over 0 is undefined. And if you put that in your calculator, it'll give you an error. So that means you cannot, in the set of real numbers, you cannot put the 0 inside of this function. So that's what that means to find the domain of the function, the set of all the input that I can put inside of it. Now, and here this case is, okay, I know exactly which one I cannot put in it. I know I cannot put 0 in there. But whenever you have a function, the way you know which values, because you could start listing all the values that you can put inside a function. I can say I can put 13 here, 4.5, 16, -12. It would take me a long time. So what I just simply do is for the domain, I said, okay, it's the set of all x values such that x is different from 0. Because when it's 0, this doesn't make sense. Now, it's the same thing for the range. The range, set of all the y values, domain, set of x values. The range is a set of output. So whenever you put the input inside of the function, what output can you possibly get? So for all the input, for all the things that we can put in the inside of the oven, what are the possible things you can get out? Can you put something in the oven and end up with a brand new car? No, probably not. It depends on what type of oven you have. So the one that you cook your chicken at home, you can put chicken on it, you can put vegetables, you can put other things on there, but you cannot put, you cannot just out of nowhere just throw a notebook in there and think that you're gonna have something meaningful. So meaningful for me means in terms of R. That makes sense in R. And when you have a function like this, there is certain values that you cannot put in it. There's certain values that when you put in, there's certain output that are not possible. Some of the function that we're going to see here. There's certain output that are not possible. So the range is all the possible y values. And likewise, the same as domain, when we find in the range, so what we say is the x, the set of all y values such that x has some property. So you would say, x could be greater than 0, or x could be different from 3. It doesn't really matter. So that's how we know them. So let's do some examples so you can understand what I'm saying. Remember, what we're going to remember is domain is set of input, range, set of output, possible input, domain, all possible output, range. Let's see if you guys have any questions. YouTube, no. Let's see, TikTok. You guys understand? Yes, no, maybe, perhaps. Let's see. Thank you, no problem. Fendi Durag. Thank you. Is it Dowry Head Donkey 69? Thank you, no problem. I appreciate you. All right, cool. All right, so yeah, you guys understand. All right, cool. Glad you understand. Okay, so now let's move on. So we know what a domain is, we know what a range is, so we're gonna move on. So now we're gonna find how to calculate them when we have real function. So we have the first function here is the function g of x is equal to square root of x 8x minus 1. If you can find a domain and you say it before I say it, I'll give you a big shout out. Whoever says before I say it, but I'll show you how to do it. And then maybe in the other one, you can try to help me solve for it. So on the first one right here, so this is what we're going to do is saying, okay, what are all the possible x values? The first thing I know about square root is I cannot go in my calculator and say square root of -3. If I put that in my calculator, it's going to give me an error message because in R, and instead of real numbers, this is not possible. So you cannot take the square root of -3. So what I need, but I can take the square root of 0, the square root of 5, the square root of 500, 0.000000001, but -1, -5, no, you cannot take those square root of them. So what I need is the set of everything that's underneath the radical needs to be greater than or equal to 0. So that's what I'm going to do here. I'm going to set this thing greater than or equal to 0. And after I do it, I will take a few examples. You'll see what I mean. So let's use one of the greatest erasers of all time, which is a shirt. I can't find where I put my eraser. So let's set this greater than 8x minus 1. We're going to set that greater than or equal to 0 because that's how we want it to be. Want it to be either greater than 0 or equal to it. So 8x minus 1 greater than or equal to 0. So now we're going to add 1 to both sides. Positive 1. 8x, this one is gone, is greater than 1. Now we divide both sides by 8. And we have x is greater than or equal to 1 over 8. Now, the set of all values that are greater than or equal to 1 over 8. So those are all the possible values that we can put inside this function. So 1 over 8, you guys know what that is. What is it? 1/4 is 2.5, 0.125. So it's probably 0.125. So 1 over 8, whatever that number is, every x values that I'm gonna that I need to plug in here, it needs to be greater than it. So if I put in 0 here, square root of 0, if I put in 0 for x, 0 times 8 minus 1, is that a possible value? Can I possibly put 0 inside of the for x? Can I have g of 0? Does that exist? Which would mean 8 times 0 minus 1. Does that exist? Is that a possible thing that I can plug in? Let's see. Yes, no. Can I plug in 0 for x in this case? No, that's why. That's right. No, that's right. That's right. That's right. Good. You cannot put 0 here because what happened is when you put 0, and I'm going to use the famous eraser again. When you put 0, what you have is the square root of 8 times 0 is 0 minus 1, which means the square root of -1. So that means in the set of real numbers, this is not possible. It's not a possible value. So that means 0 cannot be in it. Remember, what we found is x needs to be greater than or equal to 1 over 8. Can I put 1 over 8 inside of here? Inside of this? Can I put 1 over 8? So that what I'm saying by that is can I calculate g of 1 over 8? We already saw we cannot calculate g of 0. Can I calculate g of 1 over 8? Let me see. TikTok. Can I calculate g of 1 over 8? What you need help with on trick? Let me, I might do a little bit of some. G of 1 over 8. Is that something that's possible? Can I calculate g of 1 over 8? Yes, no, maybe. No. And yeah, that's right. You cannot, you said no. Oh, I thought you said yes. Yes, you can. Noelis Perez. Yes, you can. You can. So what I said is the value of x needs to be greater than or equal to 1 over 8. So that means it can be greater than 1 over 8, but it can also be equal to it. That's what this thing right here says. So if I put 1 over 8 inside of this function, I'm going to have the square root of 8 times 1 over 8 minus 1. 8 times 1 over 8, this 8 is canceled, so I have the square root of 1 minus 1, which is the square root of 0. Yes, that exists, square root of 0, which is equal to 0. So that means you can put 1 over 8. So everything that is greater than 1 over 8 is part of the solution. -5 is not part of it, but 5 is part of it. 1 is part of it because 1 is greater than 1 over 8. Now, let's move on. If you have any questions, let me know. Let's move on to what range is. So we saw a domain. They say, hey, that's the set of all values for which the inputs for which the function, for which you can have a possible output. Now, what's the range? The range, think about y values, is the set of possible outputs. So what are the outputs of here? So I have g of x is equal to 8x minus 1. Now, what do we know about square root? So when you put anything inside of the square root, not only it needs to be positive or 0, but also it spits out, it gives you something else that's always 0 or greater. So Now, based off of that, what would you say the range is? And I won't take long in it to answer it. So based off of what I just said, the square root function will be something that is either 0 or positive. So it will either be 0 or greater than 0. So greater than or equal to 0. So what possible value, what's the set, what's the domain? So would it be x? So what's the value, what's the property of x here? So what's the domain? What's the range, sorry? What's the range? What are the set of all output that we have here? Is it x of what? What's the property that I'm looking for? Let me ask this another way. The range is the set of all output. And I just told you guys, the square root function, it takes values, not only it takes values that are positive, everything underneath the square root needs to be positive or 0, but whatever it spits out is also 0 or greater than 0. So now, based off of that, what is the range of this? So what are the possible values that this function g of x is going to spit out? So can it spit out a -5? Can it spit out a -1? Or positive 15, or 0, or 5? So what are all the possible values? Let's see, we'll get it. If somebody gets it, I'll give you a big shout out. If not, I'll continue. Let's see. The range. How do you find the measures of any given angles for trigonometry? I would have to see the problem. Yeah, you would have to. I would have to see the problem that you're referring to. I can go into a relation between the circle and the measure of an angle inside of a circle. I can go into that, but I'm curious to see what you're working on. Okay, so the possible y values are possible y values needs to be greater than or equal to 0. So that means everything that this function is going to spit out is always going to be greater than or equal to 0. Those are the possible y values. Now, that's the second one. So if we're done with this, let's try the second one. Oh, I didn't have to erase this. I need it. I actually need to find the zeros, but I'll put it back. Let's put it here. G of x is equal to square root of 8x minus 1, I think. All right, so now we calculated the domain of this function. Domain, possible x values. Now we have here, it's the same scenario. Even if they have the -1 in front of here, what the scenario is I'm not even going to focus on -1 because it's constant. It's still going to stay the same. I'm going to focus on this guy right here. This, whatever is underneath the radical, needs to be greater than 0 or equal to 0. So that means x plus 2 greater than or equal to 0. You add -2 to both sides. X is greater than or equal to -2. So that means the possible values for the domain is all of x greater than or equal to -2. Let me ask you some questions. Can you plug in the value of -1? Can I plug in -1 inside of here? I'll give you guys 10 seconds to answer. 9, 8, 7, 6, 5, 4, 3, 2, 1. Yes, somebody say no. No, you cannot. Okay. Let's see. Who else? Any other answer? Yes, you can, because -1 is greater than -2. So anything that's greater than -2 is a possible value. Yes, you can, because whenever you plug in here, you gotta try it too. You can try it too. -1 plus 2 is what? -1 plus 2. 2 minus 1 is 1. Square root of 1, which is 1. -5, you cannot put it here because it's smaller than this. So yeah, that's how you find the domain for this one. Now, how do you find the range for this? So if I want to find the range of this, and I'll probably go into trig after that. I'll show you guys how to find the zeros, the intercepts and the zeros. I'll go into trig after that. So if I want to find the range of this, the range is the possible y values. So all the values that the function can spit out. So here we know that the f of x function is equal to -1 plus the square root of x plus 2. Okay. Now we also know the square root function needs to be greater than 0. So like we saw here, the square root function always outputs greater than 0. So that means the square root of x plus 2 is greater than or equal to 0. Those are the outputs that are possible. Now, what happens if I add -1 to both sides? -1 on here, -1 on here. So that means -1 plus the square root of x plus 2 is greater than or equal to -1. What does that mean? That means f of x or y is greater than or equal to -1, because that's f of x. Everything is f of x. Everything right here is f of x. That means it's greater than or equal to -1. So that means the possible outputs for this function is everything that's greater than or equal to -1. Let me go into something a little bit different. So let's do the intercepts. I'll explain this for you a little bit, and then we'll do one example, and then after that we're probably gonna move to trig and actually this first. The person who asked this question, let me know if you're still here, so I can help you. So intercepts or zeros. Let's say we graph the function this way. So let's say this is the graph of the function. We want to find the zeros of the function. The intercept means, as the name sounds, intercept, like it cuts it somewhere. So it cuts the x and y axis somewhere. So the y-intercept, it cuts it, it cuts the y-axis. The x-intercept, it cuts the x-axis, crosses the x-axis. So now notice, when you have this point right here, let's say this was right here is 5, let's say this is 1. This point right here would be the point 0. X is equal to 1, y is equal to 0. This point right here would be the one x is equal to 5, y is equal to 0. Those are the x-intercepts. And you could do this, the function could look anyhow you want it. And this point right here, let's say this is 2. That means x is equal to 0, y is equal to 2. Now notice what happened. When the function crosses the x-axis, y is equal to 0. And when the function crosses the y-axis, x is equal to 0. So now, when we're finding the x-intercept, tell me what value we're going to set equal to 0. I just said it. Let me say it again. When the function crosses the x-axis, which is the x-intercept, y is equal to 0. When the function, you see, y equal to 0, y equal to 0. When the function crosses the y-axis, x is equal to 0. X is equal to 0 right here. Now, if I'm calculating the x-intercept, what values I need to set equal to 0? X or y? Let's see. I know you guys are smart. Come on. Oh, Lord. Let's see. Y, that's right. That's right. Y. That's what I'm talking about. Y. High 39, you said X. Okay. Why'd you say X? So yeah, high 39, let me explain it again. When the function crosses the x-axis, y is equal to 0. You see? 1 is 0. X is equal to 1, y is equal to 0. 5, 0. X is equal to 5, y is equal to 0. So when it crosses the x-axis, the value of y is 0. When it intersects the y-axis, x is equal to 0. So if I'm finding the x-intercept, I'm going to set y is equal to 0. If I'm finding the y-intercept, I'm going to set x is equal to 0. So now I'm finding the x-intercept. That means I'm setting y equal to 0. G of x, which is the same thing as saying y, is equal to square root of 8x minus 1. How do I solve for this? I say when I'm finding the x-intercept, I'm going to set y is equal to 0. So that means this y right here is going to turn into a 0. This is going to square root of 8x minus 1. If you find this before me, let me know. So how do we solve for this? We square both sides. Square both sides of this equation. 0 squared is equal to the square root of 8x minus 1 squared. 0 squared is 0. square root of 8x minus 1 squared is 8x minus 1. And what you do, you add them on both sides. Add 1, add 1. 1 is equal to 8x. You divide both sides by 8. X is equal to 1 over 8. Now, what is that saying? This function crosses at x-axis at the point x is equal to 1 over 8. And then y is equal to 0. Because I said y is equal to 0, x is equal to 1 over 8. Does that make sense? Let me know if you guys understand. Hold on. Am I making any sense, guys? Yes, no, maybe? I'm glad I could help. Yeah, that makes sense. All right, cool. All right, so now tell me when I'm finding the y-intercept. All right, good. Okay, we're gonna go back. Okay, cool. We're gonna go back and do yours after I'm done with this. So let's say I'm trying to find the y-intercept. So now I'm not solving for the x-intercept anymore. So I'm saying, hey, what's the y-intercept? Y-intercept. Y-intercept. What value do I need to set equal to 0? So I'm calculating the y-intercept. G of x is equal to square root of 8x minus 1. What value do I need to set equal to 0? Let's see. Let me see who's going to get the shout out. This could be algebra 2. This could be calculus. It could be pre-calc. But this is like a review of functions. So you probably see this in algebra 2. Algebra 2 most likely. I don't know if you do it in algebra 1, but algebra 2 most likely you'll see that, and then they'll do it in pre-calc maybe, and then in calculus. He's so confused. What class are you in a I-39? All right, so if I'm finding the y-intercept, I'm going to set x is equal to 0. The same thing I said earlier, y-intercept, I said x is equal to 0. So that means y is equal to, I'm going to set x is equal to 0. 8 times a 0 minus 1. Y is equal to 8 times 0 is 0. Square root of negative 1. Now, what does that tell you? Square root of negative 1, that doesn't exist. So that means the function doesn't cross the y-axis. So that means there's no y-intercept. No y-intercept. No y-intercept. All right, so no y-intercepts. So how do we yeah. So that's what we do. Let me go solve for something quick that someone asked me to solve. So I know she said she's here. Let's go to this question. And after that we could do some stuff about trig. It'll be more like tricks and stuff. Okay, so we have, this is what she's solving. She's trying to find what's the value here. And let me know if I write this correctly. I'm going to assume that I write it correctly because last time I said to check it for me. So this is what we're solving for. We have, who can tell me what this is going to be equal to? Let's see. So we have negative 3 to the third power, and then you have a negative sign here. So now, when you're thinking about powers, what you want to do is when you have powers, you're solving for stuff. What you want to do is, keep repeating that stuff. Keep repeating whatever you have. So what I'm saying here is this is the base. Negative 3 is the base. The power is 3. So what that tells me is just take the negative 3, multiply it by itself 3 times. I'm going to leave this sign out by itself, the sign. And then I'll show you, I'm going to do it in a tedious way, but after that, I'll show you how to, a good way to think about it. I'm going to leave the negative sign. This negative sign, this is it right here. I'm going to leave it out. And then I'm going to take the negative 3 that's inside of the parenthesis. I'm not going to change it. I'm going to multiply it by itself 3 times. That's what the power tells you. The power says, hey, do you have negative 3? That's the base. Multiply it by itself 3 times. And what do you get? So let's go. Positive, now negative times a negative, that gives you a positive. A positive times another negative, that gives you a negative. So, or you could say negative 3 times negative 3, that's negative 9. 9, that would be 9, sorry. Negative 3 times negative 3, that gives you 9. 9 times negative 3, that gives you negative 27. Or you could say, you could do the signs first. A negative times another negative, that gives you a positive, times another negative, that gives you another negative. So negative 3, and I'm not touching this yet. Negative, so that would be a negative sign. And then I do the numbers. 3 times 3, 9, times another 3, that's 27. Negative 27. And outside, I still have a black negative sign that I never touch. Cool. Now, negative times a negative, that's a positive. So this negative times this negative, that gives you positive. So that would be 27. And that's how I would solve this. So I'll show you another way. Do you guys understand? Let me see if you understand. Uh-oh. I don't know why this is showing this. Okay, do you guys understand? Thanks. Easy than I thought. No problem. Hopefully they wrote it that way for you. I hope. I want you to smile. Thank you very much. Yeah, hopefully it was like that in your book. I don't want to, if I wrote it the wrong way, let me know. It's so helpful. No problem. All right, cool. No problem. Okay, good. Now, and your college pen notes will. Okay, yeah. So that's how you should solve for it. Now, this was the very tedious way, because they could give you what's negative 3 times, to the third power. Negative 3 to the power of 31. Now, here's one thing I wanted to tell you is you could put this in your calculator, but I'm assuming that they don't want you to use a calculator. This is what you would do in this case is, let me take the 31 out. So in the case that there's another way that you can get the 27 faster. So this is what I would do. If I was solving for this, I get into it. I say, hey, this is the base, negative 3. So I'm going to do the powers and the sign. I'm going to do it another way for you. It's kind of like you have a negative 1. So let me take this black negative out. I'm going to leave it red. I'm going to take this out, leave it the same way it is. And I'm dealing with this now. So this is what I would do. What you could say is negative, this is like negative 1 times 3, right? Negative 3 is negative 1 times 3. This is like negative 1 to the third times 3 to the third, right? What's negative 1 to the third? Now, there's 2 ways to think about that. You could say it's negative 1 times negative 1 times negative 1. That gives you a negative 1. Or you could say, the better way to say that is saying, because the power is odd, what I'm going to get is going to be a negative. So a negative sign, if the power is odd, the sign is going to remain negative. So if I have a negative base, base that's negative, because the power is odd, it's not even. If I had this to the 4th power, it would be a positive. If I had it to the 0th power, it would be 1, but it would be positive. Now, because the power is odd, is 3, the negative sign is going to stay negative. If the power was even, 6, 8, 9, it would be positive. So that means this is going to stay as negative 1. It won't change. If the power was 40, it's even, it would have been 1. And then you just multiply the 1 by this one. So in this case, what you would do is saying, hey, because the power is odd, it's not an even power. So this is going to give me negative 1. I know that for sure. And then 3 to the third is 27. 3 times 3 times 3. So 27. So what that would make is, that would give you the inside would be negative 1 times 27, negative 27. And times that red negative that I never changed, a negative times a negative is a positive. That gives you 27. So A way to deal with this is saying, okay, I have a negative base. Let me see what the power is. If it's even, it's still gonna stay negative. If it's odd, it's gonna if it's odd, it's still gonna stay negative. If it's even, it's gonna become positive. And then after that, you just multiply it by that negative one that was in front of you. Does that make sense? Let me see. You guys understand this a little bit better. Oh Lord, Jesus Christ. Sorry. Yeah, do you guys understand this a little bit better? Let's see. Let me know if you understand. Yes, no, maybe, perhaps. Oh. Hey, when this does that. Yeah, if you understand, let me know. Way easier to understand. Thank you. Makes sense. Thanks. Yes. Good. Nice. All right, I'm glad you guys understand. That's what's up. Cool. Yeah, so that's another way to do it. This doesn't have nothing to do with the title. Let me erase everything and try to see if I can help with trig. So somebody was saying about if you have an angle and you want to measure it. I don't know. I didn't get the full detail of it. So let's say if you had a little trick that I'm gonna show you in trig that you can do. I don't know. I didn't see the problem or anything. So I'm gonna show you a little bit of trick, a little trick that you can do in trig. And we do this almost every time, the unit circle thing. So let's say you have a unit circle here. You have, if you have an angle like this, they say this angle is 45 degrees. If you have this angle, they say, hey, it's 45 degrees, this angle. And they ask you to, and then they say the radius of the circle is radius R is equal to 3. And then they could ask you for the length of this arc. The other common question is for them to ask you for, let me find another color. The other common question is for them to ask you for the area of this shaded region. And these two questions are very common in trig. I don't know if that's what you're solving for. I didn't see your question. Let me know if that's related to what you're solving for, and I'll show you how to do it easily. Thank you. Thank you, Chicken Wing 162. You guys are clever. The names are hilarious. Who else is taking note? I'm not. I'm writing. So let's say you had a circle this way, and you have the radius of the circle, and he said, hey, what's the length of this arc right here? Normally they talk about the arc that subtends the circle, the angle of 45 degrees. So let's say they ask you for the length of this arc, and you have no idea how to do it. So what I like to say is relating the circle to this angle right here. So I say for a circle, I know the length of the arc of a circle is 2 pi r. And I relate that to inside of a circle. How many degrees do we have inside of a circle? Who can tell me this pretty fast? How many degrees inside of this whole circle? Inside of a circle, how many degrees? I wouldn't know. I wouldn't know how much it is. Good job, Mary Costellos. Good job, Lo Presky. Good job, Chicken Ring 62. That's what's up. 0.14. I'm not sure where you get that from. Are you answering the whole question? Yeah, high 39. Yeah, so yeah, whenever a lot of times they say, hey, you could remember this, it's equal to this. So whenever they telling you, hey, I have a circle, there's a little bit of they cut out a piece of a pie. It's 45 degrees, and then they say, hey, what's the length of this thing right here in the red? What's the length of it? So what I do is I say, okay, I'm going to relate the whole circle to the little bit of piece that's inside of the circle, and I'll show you how I do that. So I say, I'm going to write everything in red in the first one. I say the whole circle, which is actually, so that's fine. The whole circle is the length of, the circumference of the circle, the length of the perimeter of the circle. The whole thing is 2 pi r, and I relate that to how many degrees inside of the circle, 360 degrees. And if they had given me that in radian, I would put 2 pi radian in here. So 2 pi r, 360 degrees, for 45 degrees, which is a little bit of it, how much I'm gonna get for this is the this is the circumference, or the perimeter of the circle. Perimeter. And then on this side is perimeter, x. And on that side is what? It's the degrees, how many degrees are inside of the circle. So 2 pi r, which is the perimeter, corresponds to 360 degrees. So I'm saying inside of a circle that's 360 degrees, the perimeter is 2 pi r. Inside of a little bit of a circle, which is 45 degrees, a little bit of it, the perimeter would be what? And you just cross multiply and you'll find it. So usually this is how I do it. I don't memorize much of this. So let's say 2 pi times r, which is 3, multiply by 45, and you divide that by 360 degrees. So what I just did here, I multiply this guy by this guy, I multiply this guy by x, and I solve for x. X would be this. So let me do the step one so I don't confuse you. So it says 45 degrees multiplied by 2 pi r is equal to 360 degrees multiplied by x, and then I divide both sides by 360 degrees. That's gone, and that's what's here. So, and you put that in your calculator, you should find a value for x. Same thing if they ask you for, and I'll show you how it's the same because I won't change much out here. So same thing as they ask you for area. So this was perimeter. Perimeter. Let's say if they ask you for, okay, what's the area of this shaded region right here? This little thing, this little piece of thing right here. So I just go and find the area. Now, what's the area of a circle? Who can tell me what's the area of a circle? Let me see. Let me see if you can tell me what's the area of the circle. So I'm going to relate area to area. Area of a circle. Area of a circle. Who can tell me what it is? I won't give you too much time. Let's see. They could they could ask you to calculate the. They could ask you to calculate. I'll show you in a little bit. I say this is better than the Zoom class. Equal pi times radius. Okay, you could ask you to calculate it. In here, you could just put 3.14 for pi. There's also calculators that has the pi function in it. Let me see my calculator at one of them at least. There's also some calculator that has a pi function on it. You can just put pi. So it really doesn't matter how you want to do it. I don't see what I put my calculator is on. So you could just do 45 times 2 times 3.14, sorry, times r, which is 3. And then you just divide it by 360 degrees. So you could do that. Some function, some calculator, they have pi. And sometimes, depending if you enter in, you have enter choices, they leave it in terms of pi. So what they do, they leave the pi and they don't replace it by nothing. And then I would give 90 times 3 was 270. I would say 270 divided by 360 pi. And then they would simplify this, however it simplifies to, they would say something pi. They could give you the answer that way. they could give you the answer that way too. So it depends on how the answer choices that they give you, especially if you're taking like SAT and stuff like that. So it depends on the answer choices. Let me show you how you would do this. So the same thing that I did in this one, I'm going to relate the area. Let's say if they had asked me for the area, I'm going to relate the area of a circle to the area of to the sum of the degrees inside of a circle. So the area of a circle is what? 2 is pi r squared. I asked you guys, I don't think you remember. So pi r squared corresponds to 360 degrees. So for the whole 360 degrees that's inside of the circle, I have pi r squared. That's the area. For this little tiny piece, that they cut out of it, which is 45, what does that correspond to? And I'll do the same thing. Cross multiply, so it's going to be 45 times pi r squared, 45 pi r squared is equal to x times 365. 360. I don't know why I keep saying 365. 360. And you divide both sides by 360. And then you find x would be that. And notice it's different from there. This is 2 pi r, this is pi r squared. So that's for area, this one is for perimeter. And if they ask you for the length of the arc, you would do this. And you could find a way to memorize the formula if that saves you time. But a lot of times you could just do this by hand and just put all of these in your calculator at once, and you about to get the answer. Any questions, guys? Let me see what you have. Tell me. Maybe I should tell you. Yeah, that's probably from 365 days. Yeah, that's why I was saying 365. Yeah, that's probably why I say 365. Calculator, I gave you guys a good one last time. And that's, what is it called? The yellow calculator that I showed you guys. What is it? Is it TI-30 multi-view calculator? It's something 30 multi-view calculator. I don't see why I put my calculator. That is the bomb. When I tell you it is good, it's like you can, if you're doing divisions, you can put the actual divisions on it. If you're doing stats, it has stuff where you can put the data and gives you everything. If you're taking any class, I think it's called TI-30 multi-view calculator. And when you see it, you'll think it's something simple, but it's a complete machine. I like it. I've been using it for a while, and I haven't had any problem with it. I remember I had to buy another calculator for a financial math class that I was taking, but most of the class, this will help you a lot. Now, if you're graphing functions and stuff like that, it has graphs in it. It's probably better to use like a, what's called TI-84, TI-85, 83. It's probably better. Those are probably better for that. But if you're doing like simple calculations or stats specifically, just TI-30 multi-view. I think that's what it's called, TI-30. I can't pull my calculator out. It's probably somewhere in the house. Yeah. Okay, so let me see if you guys have any questions. Let's see. Any questions, guys? YouTube. Three 17. 3 times. Okay. Let's see. TikTok, any questions? No questions. All right, so long division. Okay, let's do some long division. Um, let's see. I don't know if you do it in the context of functions. That's a different one when you divide a function by another one. But if you do like the simple regular long division, let's see if we can do some of these. And it's gonna be funny because I don't use the way that you guys do division. That's not how I learned it. So sometimes I don't put the stuff where they're supposed to go. So let's say I have 1, 7, 2, 3, something like that, divided by. I don't have a calculator. I gotta find something that I know I answer to. So let's say I'm doing this. I'm doing long division. So I have 1,723 divided by 5, and I want to know what the answer to that is. So the first thing I want to do is saying, okay, now if I have 1, if I take 1, how many times 1 go into 5? 1 is smaller than 5, so it doesn't go into 5 any time. So now let's go 2. How many times does this 17 goes into 5? 17 goes into 5 how many times? How many 5 we have in 17? So let's say I have 1 5, another 5, another 5. That gives me 15. So it's 17 right here. So I have 2 left. So that goes into 5 3 times. 3 times 5, 15, 17. 5 goes into 17 3 times. So 5 and 5 goes into 17 3 times. 3 times 5 is 15. 17, and then what you put here is negative 15. The reason why I'm going to put negative 15 here is because you want to take that away from whatever you had here. So you're going to take that away from it. Does that make sense? Let me see if you have any question. The person who asked for about long division. What advanced function do you need help with? Yeah, 0. Yes. Okay. So yeah. Okay. Yeah. So the reason why. Oh shoot. I'm bad. TikTok. I messed this whole thing up. All right. Let's see. This should help. Yes. Okay. So the reason why you put the negative 15 here is because I'm going to say, hey, I'm going to subtract that from whatever the 17 was. So now what I'll do is I can put a bar right here if I want to. I said, so I can put the bar right here. So I say, in 15, 17 minus 15, you got the 2 here. Now what I'm going to do is take that next digit that comes up and put it right here. All right. So I'm here, 22. How many 5s that there is in 22? Let me count. 5 plus 5 is 10. Plus another 5 is 15. Plus another 5 is 20. If I add another 5, I'm going to be 25. That's more than 22. So that means there's going to be 20, and there's going to be a 2 left. And the 2 that was left here is this 2. So what I do here is saying, hey, okay, 22, 5, 5 goes into 22 like 3 times. 4 times, sorry. I said 4 times. 4 times 5, 20. So I take the 20. I put a negative 20 here. The reason why I put negative 20, the same thing as earlier, is because I want to take that away from this 22. And what's left is the remainder. So it goes into it, it goes into, so there's 4 5s and 22. And then I had a whole 20, and there's 4 5s and 22. This was 22. So the 4 5s, 4 times 5 give me 20. And what you do is saying, okay, I have 20. 4 times 5 give me 20. This 20, I put it right here, and I put a negative side of it because I'm going to take that away from 22, which I need a remainder. The remainder is going to be giving me 2. And you do the same thing. You keep doing the same thing until you finish. So the 2 here, I'm going to bring down this 3. 2 3, 23, right? How many 5 that there is in there? So say it's 1 5, 2 5, 3 5, 4 5. And if I take another 5 again, that's going to give me 25. That's too much. 22, 23, 20 plus 3. So what does that do? So what does that do? So 23. So how many 5 that we found? 1, 2, 3, 4. 4. 4 times 5, 20, minus 20. And then the remainder is 3. So let's call the remainder. Oh, let's see YouTube looking at this. YouTube. So yeah, this is the remainder. You have a remainder of 3. And that's how you would do on division. So the way we started is we're saying, okay, consider these 2 right here. So how many 5 there was in 17? There was 3 5. I multiplied the 3 by the 5. That gives me 15. And then I put negative 15 right here. So I subtract this from this, and there's the remainder of 2. And I bring down the next digit, 22. Once I'm done with that, I bring down the next digit. So when I was at 22 right here, so I said, hey, how many 5 there is in 22? There's 4 of them, because 4 times 5, 20. And then there's a remainder of 2. And then I bring down the 3 here. There's 4 of them again. There's a remainder of 3 is what we have as a remainder. So, and if you multiply this guy by this guy, you're going to get something very, very close to this. But if you add the 3 to it, it will give you that. So what I'm saying is if I multiply 344 by 5, I'm going to get something very, very close to 1723. If I add the 3 to it, the remainder, that's why. The reason why I had the remainder here is because this is not 5 yet. This is just a little baby 3. It needs 2 more to be a 5. So that's why, to give you that remainder. Remainder could be 0, 1, 2, 3, or 4. It cannot be 5 or greater. Does that make sense? Is that making sense? The long division question. Oh man, this is gone. Yeah, my phone is losing its charge. It's gone. Let's see. Yeah, my phone is at a low percent, so it was sending me a notification. Yeah, I'm here. Let's see. This is way more complicated. He said it's way more complicated when it get hot. When it get hot. Okay, I understand. Glad you understand. Okay, thank you. All right, cool. What did I miss? Somebody say I didn't notice something. What did I miss, guys? Let's see. Oh, you said it's supposed to be above the 7? Yeah. Yeah, you're right. I was just trying to explain the concept. Be fast. 3, 0. Yeah. Yeah, technically it's supposed to be above the 7 also. So yeah. That's how you do it. I'm glad that you understand the concept. I agree with you. Above 3. Jordan, correct 20. That's what's up. Thank you. Thank you. Thank you. Thank you. 344 times 5. Yeah. So yeah, let me see if you guys have any other questions. Mario, thank you for the rainbow puke. No problem, Maria Castellanos. I go live every Tuesday. Um, Bra Russia Hid. Send me what you're working on for log function. 904-299-8417. Yeah, so I'll go live every Tuesday, and I know you guys are in the summer now, so when school starts, I will I'll make that more a little bit earlier because I know you're probably gonna have to go to sleep to get ready for class, so it'll start a little bit earlier. But yeah, I come live here every Tuesday. Question YouTube? No, maybe. Yeah, it's about to be that time, guys. I really appreciate you all coming around. So hopefully, what class are you taking? Chicken wing 62. No problem. My pleasure. Pre-calc. Okay, cool. Yeah. I'll be doing some stuff here on pre-calc. Yeah. Uh, I hope I can help you guys this semester too. So I'll be doing this every Tuesday, and um, yeah. So every Tuesday I'll be coming here and I'll help you guys. Swish 21B, thanks for the follow. Um, so I used to say now when doing school time, I'm probably gonna come live. I'm thinking between 8 and 9, 9:30 the latest. But now I just I come live between 9, 10, and sometimes it could be like 10:30. So tonight I didn't even come here until like 11. But when school started, it's probably gonna be, and then usually when I do those, so the way I normally would do it, I know you guys are in school or like mostly on vacation now. The way I normally you would do this is I would post. So if you follow me, you would see the post on Tuesday, and then I would post the time, in Eastern time that it's gonna be live, and then you just come around that time. So um, yeah, so I'll be doing that more consistently when school started again. But I'm always live on Tuesday. I try to make sure I make it on Tuesday, so I get in the habit of doing it. I'll come live and help you, Jeanette. I'll come live and help you. Are you taking it now or are you taking it next semester? Jeanette, are you taking Algebra 1 now or are you taking it next semester? And I'll be live every Tuesday to help you. So That should be, and there's also a number too where you can send stuff. So if you're taking it now, you can send stuff, and then when I come here, I'll just solve for it. Uh, okay, okay, okay. Yeah, come back and come back here every Tuesday. I'll help you. And when you start getting homework, you can send it to that number. No problem, Kate. Uh, no problem, Kate on YouTube. Yeah, thanks. All right, guys. I will see you guys next time. Possibly next Tuesday. Stay tuned. I'll be posting stuff too. So if you have any questions, you can send them to the same number 904-299-8417. And what's his name? The guy who asked about log function. You can, if you, unless you want to generate help, which we do, I've done here. If you're working on something specific, just send it to me. Send it to me at to 904-299-8417. So you can just screenshot it and send it to me, and I'll be able to help you and see what you're working on. Yeah. All right. Thank you guys, and I appreciate y'all coming in. I'll see you guys later.